Hey there! Welcome to this lesson on chunking strategies. We're going to focus on two main types, fixed size and recursive chunking. First off, why is chunking even necessary for building good retrieval augmented generation, or RAG, systems? Well, large documents are a big hurdle in natural language processing, and chunking is our main way to handle them. Basically, chunking is vital for RAG systems so they can process big documents within model limits, get better retrieval results, and create higher quality embeddings. You see, a lot of enterprise documents are just way too big for current natural language processing models to handle all at once. These models have something called a context window, a limit on how much text they can actually look at. If you try to shove an entire huge document into a model that can only handle a few thousand words, it's just not going to work correctly. So, the main point here is, chunking breaks down large documents to fit what models can handle and to improve search results. Okay, now that we know why chunking is so important, let's jump into our first method, fixed size chunking. This is where we split documents into pieces that are all the same size. It's pretty simple, but there's a trade-off to consider, especially when it comes to keeping the meaning intact. With fixed size chunking, we just pick a size, usually in tokens or characters, and stick to it. You read the document, grab a chunk of that exact size, and then start over from the next word. It's a very mechanical way to break things up. The key thing to remember is, fixed size chunking is easy, but it might split up sentences or ideas in awkward places. We've talked about fixed size chunking, so now let's look at recursive chunking. Unlike the fixed size method that just cuts things arbitrarily, recursive chunking uses different separators and stages to try and keep related ideas together. It's a more thoughtful approach. How does recursive chunking actually work? Well, it starts by splitting the document with a main set of separators, often things like paragraphs. If any of those chunks are still too big, it repeats the process, splitting those chunks again, but this time using smaller separators like line breaks or even sentences. It keeps doing this until all the chunks are the right size. This method is great because it usually keeps related information together by following the document's natural structure. It's also more flexible for documents that have different kinds of formatting. The downside? It's a bit more complicated to set up because you need to manage these different separators and the logic for repeating the splits. Also, the chunk sizes might end up being more varied, and you could potentially split things too much if the document is very dense. Essentially, recursive chunking prioritizes keeping the meaning intact, even if it means a bit more work to implement. So, the core idea is, recursive chunking uses the document structure to help preserve the meaning. We've now gone through both fixed size and recursive chunking. Let's talk about how these apply specifically in enterprise RAG systems, where getting the right answer is super important. In enterprise settings, your chunking choice really matters. Think about finance or legal fields, precision is everything. With fixed size chunking, you risk cutting off ideas, which could lead to big misunderstandings. Technical docs, though, they often work better with recursive chunking because it keeps those logical information groups together. And if you have a complex question that needs info from different parts of a document, keeping the meaning intact with recursive chunking is key. Bottom line, for many enterprise users, the ease of fixed-size chunking just isn't worth the high risk of breaking up the context. That can be a major problem when accuracy is critical. So, the main takeaway is, always prioritize keeping the meaning intact to ensure accuracy. With these strategies in mind, you should be able to pick the best one for your RAG setup. Coming up, we'll dive into how to actually implement these chunking methods in your RAG pipelines.